full water bottle like this. This one's actually been opened. So you don't want this one.
Who?
Water bottle besides these two both being used. Sorry, but you can go down to the other hallway.
I keep trying to.
It's all the way at the other end, way past Saha's, like way at the end. So, okay. So I think what I did on this one is you left, I said something like, okay, don't ask me, I'm just gonna write it down real quick and multiply it out. But let's do it real quick to show you. I'm actually gonna take this square, and since it's not like the sign squared, it's like the whole expression squared. I'm gonna go ahead and FOIL that out. So it's 1 plus sine of theta times 1 plus sine of theta. So I'm just gonna use this as scratch paper. We'll just kind of set this aside, kind of some scratch area, and actually multiply all that out.
Mr. Phillips?
Yes.
I have a question.
Sure.
If if there's multiple ways to find one answer, how would you know your answer is right?
Okay, so that's a deeper question. Let's finish the problem, then we'll get into that. Okay. So I'm gonna go ahead and FOIL this out. So 1 times 1 gives me 1 plus sine of theta. Sine theta times 1 is plus sine of theta. And sine times sine is plus sine squared of theta. That's a good thing when you see a sine squared and a sine squared here. That's a good thing. So I have 1 plus 2 sine of theta plus sine squared of theta. If you still have your notes from yesterday, I believe that's what I wrote down.
Mr. Phillips,
Yes.
why is it on the other side of the equal sign?
Okay, so this is just sort of scratch paper. I could have done it on the chalkboard, but then the camera can't see it. I could have done it over there, but then you couldn't see it. I could have gone to a different paper, but then I have to go back and forth. It's way too much work. So I just wrote it there. I'll erase it here in just a second. That way it's gone, but it's just sort of scratch paper. All right, so I'm gonna have, I'm gonna replace 1 plus sine of theta squared with what it actually is multiplied out. So I'm gonna have 1 minus sine theta plus 1 plus 2 sine of theta plus sine squared of theta all over my same denominator. Cosine of theta, 1 plus sine theta. Okay? So I'm gonna go ahead and erase this little scratch work so we don't get confused and wonder again why it's on this side of the equal sign. We'll get rid of that. Okay. No, seriously, we'll get rid of that. Equals. And I just put little dashes. Now, one thing we probably should refresh our minds is where are we headed? Remember from the original problem, we wanted cosine over 1 plus sine plus 1 plus sine over cosine to equal 2 secant. So this is where I'm headed. I want to head to 2 secant theta. Okay, that's where I want to head to. Long walk down there, isn't it?
Yes, too long.
I make that walk probably 3 times a day to refill. So I finally got 2.
Is one carbonated?
I'm sorry?
Is it one carbonated?
Is that what carbonated?
It's just the
Why
way
is
the
it-
water looks?
Just when I poured it in there, I closed it, and that's what it looks like.
Oh, you didn't look at the recipe?
Okay.
Oh, okay.
All right.
That's just a
So
simple-
what do you notice about this step here? Let's try to stay focused. Anything combine? Anything cancel? Oh, hang on. This should be 1 minus sine squared. 1 minus sine squared. I copied down the wrong one. Okay. What's something? You guys speak up. What'd you say? No. Speak up. Yes.
Can we cancel out the 1?
Well, it's 1 plus 1.
Or add it,
So we can make 1 plus 1 to be 2. Let me do that in red. So 1 plus 1 is combining like terms is 2. Okay? What else can we do?
Can you combine the sine squared theta to the other side squared theta?
Yeah, what is negative sine squared theta plus sine squared theta? Yeah, they're both zero. Negative and positive. Well, that's a good thing. We like that. So then I'm just left with plus 2 sine of theta. Once again, we're still over cosine theta 1 plus sine of theta. Equals. Okay? Now remember what we're trying to get to, right? So this 2 is going to play an important part of that, right? And what is the inverse of secant? Or the reciprocal? Cosine. So I probably want to keep this. So I probably want to keep the cosine, and I probably want to keep the 2's. Okay? So what's something I could do?
Could you cancel out sine
What'd you say? I could cancel out what?
of theta?
Not just yet.
So we're not changing anything?
Oh, we have to do something.
Minus,
Minus what? You remember you can't add or subtract to either side.
Can you,
Yes.
Can you multiply the cosecant at the 1 plus?
Factor multiplied out. That is a great idea. I just know where that would go, and that's not going to help us in this case. But if you're working on your own, absolutely try it. It actually may get you the answer. It's a great option, but in this case, I just know it's probably not going to help. Okay. Okay. That's one of those persistence things. You have to try it. If it doesn't work, start back again. Okay. Something else. It's generally the first thing I always look to do. Yes.
The 2 sine of theta in the parentheses, can you like do something with that?
Talking about 2 sine of theta and this one here.
Yeah.
The only problem with that is, and here's the hint that some of you are waiting for, the problem is this is being added. Oops, what just happened? I thought I was on writing. The problem is this is being added. 2 plus 2 sine of theta. I can't just cancel unless it's being multiplied. So I can eventually cancel out 1 plus sine of theta because it's being multiplied by cosine. But I can't just cross out the sine or cross out the 1.
But that's not what I meant. Can it be factored?
Factor what?
Like, can it turn into just just 2 over cosine of theta plus 1 plus sine of theta because they're the same.
Here's what I heard you say. Could we make it 2 cosine of theta plus 1 plus sine of theta? That's what I heard you say. Is that what you meant?
Yeah.
You're so very close. You're very close. However, we don't want this plus in here. So what we can do though is we can factor out the 2 in the denominator, in the numerator. So that it's just 1 plus sine of theta.
Over cosine of theta.
Well, we're still over the whole thing. Cosine of theta times 1 plus sine of theta.
And then they cancel out
And why do they cancel now?
because they're the same, and then you can have, because they multiply.
They're both being multiplied.
And then you could have 2 sine, 2 over cosine.
Exactly right. If you didn't see that, real quickly, we look here and we say, well, they both have a 2. That's a helpful hint that they have something in common. So take it out. So let's factor out that 2, and then lo and behold, now I have 1 plus sine of theta and 1, they're both factors. So now I can cancel. When they're being multiplied, I can cancel. Okay? Yes?
Because 2's being
To
multiplied.
get 2 secant of theta, are we gonna multiply by cosine?
We're not. We're gonna make, because what I'm left here is just 2 over cosine of theta. And then what is the reciprocal of cosine? Secant. So I can just go straight to secant theta because those are reciprocals.
Because if you look at the reciprocal, like cosine of theta is the same thing, wait.
You want to see the steps?
No, wait, I get it.
I can show you the steps real quick if you want to see them.
Is it because since you're dividing it by cosine of theta, and that way, since it's like opposite, right? If, okay, so that was 2 over the sine of theta, like the
Reciprocal.
would be 2 cosecant of theta.
That's exactly correct. Hey, well. Oh, I'm sorry. Poor Blondie. Okay, so, yes, but I don't want to leave you all hanging. I want you to see why we can just switch it. On your reciprocal sheet, what is the same as cosine? Look at the reciprocal identities. Cosine is what? It's 1 over secant, right? So it's like saying 1 over the secant of theta. Well, when I divide, I keep, change division to multiplication, and flip, keep, change, flip. So it's 2 times the secant of theta. That's how we can just go straight to 2 secant theta. Which, of course, let me finish it off and I'll answer your questions, gives us our final answers where we are. Okay? Yes?
Wouldn't it, well, because like, since they're like, reciprocal of each other, since you're dividing by cosine, you just look at it as you're multiplying by secant.
Yes. This is the baby steps, but you can just see it that way, yes. Yeah. And if you had 2 divided by tangent, that would be the same as,
2 times cosine.
exactly right, 2 times its reciprocal.
Just.
Yep. Okay, very good question.
But would
Can you go?
All right.
I think I missed this stuff. Yeah.
Right there? Okay, there you go. Very good. I thought maybe you were saying that same idea, but it wasn't
that
coming out.
yes?
I wasn't hearing it the same way, so.
Is that yesterday's?
Yes, we finished yesterday. And I am recording, so it's on YouTube. Okay. You have a question? Do you need up a little bit?
We ended at the blue.
Yes. Okay, very, very good. Okay, now, your question. Any other questions about this while she's finished writing it down? Okay, so Scholar, your question, say it again.
How do you know if the way you did it is correct?
Okay, so when I'm grading these, I am making sure I can make a connection from step to step. Okay, so did the step you take legal? Like, is cosine the reciprocal of secant? If it's not, then you made a mistake. That's an error. You can't do that. I just have to go through and make sure every step you made was accurate.
So would it be like if the way you did it was like 5 steps and you mess up on the 3rd one, so that means everything's wrong when you get it wrong?
Yes. And yes, there are times where kids have made a mistake on step 3, and they go to step 4, and then go to step 5, and step 5 they screw up again, and somehow they got the right answer. Well, that doesn't. 2 wrongs don't make it right. If you make a mathematical, it's the same thing. It's the same thing in computation. If I have 2 plus 3 times 4, if you give me 20, I have to work through and figure out how you got 20 and say it's wrong, because you added first and then you multiplied. So I have to multiply first and then same thing. I just have to walk through and see, did you do all the correct mathematical steps?
So would we have like practice like problems like in the notebook, or like that's just not gonna be a thing?
Well, in the textbook, I'll give you some practice problems in the textbook, but I'm gonna give you a handout today and we're gonna go through several examples.
Okay.
Because I want you to see, the thing with this one is there's so many ways to get from A to B. I want you to see a lot of different varieties of questions. So these are very difficult to check. You really can't check them. You have to go through them step by step and see if it's right.
Long time grading these?
I'm sorry?
You're gonna take a long time grading them.
Yeah, I hate these. I hate grading these. But
Let's skip it.
I do have an assignment though.
That's crazy.
I do have an assignment that you'll get later, probably not this week, probably next week, where I actually have, I think it's 3 or 4 that I've done, and all 4 of them are wrong. You have to find a mistake.
Oh.
Okay.
And that's difficult, because you gotta look through and you gotta say, oh, well, this makes sense, but it's not right. So, anyway, that's a good question. That's good.
I'm almost done.
Okay, you're fine. Okay, so I do have lots of different examples I wanna go through, show you different steps. Hopefully you'll get a little more confident as you see them, but remember, eventually you have to do them on your own. Okay, you have to get confident enough to do them. It does take practice. This is not something we're gonna snap our fingers and you're gonna get. I hate to say this is probably not something you're gonna get in class. You're gonna have to work outside of class to do these, because it takes a little bit of practice. I don't wanna scare you, I just wanna make sure you're prepared enough to do them.
I'm done, thank you.
You good? Okay. So, let's do another example for you. By the way, I did also copy the notes from yesterday. I'll make a copy of these and I'll put them out on Schoology so you have a copy of everything I write. But it doesn't substitute you actually writing it down. Okay, so I would encourage you to, you write it down, make sure you follow along. Okay, so another example. I'm not numbering them because I don't do the same in each class. So, another example. Let's try this one. Cosine squared of theta over 1 plus sine of theta. Must be equal to 1 minus sine of theta. All right, so if you remember yesterday, what's kind of the first step? After you write it down, you have to pick what? Which side do you want to work on? Because we're going to work on one side. So you want to pick the more complicated side. So in this case, which one would you pick? Probably the left. Okay, we have a fraction, we have two different trig functions, or here we just have 1 minus sine. Okay, so any suggestions to begin with? Can we factor anything? Can we make any substitutions? Yes.
The cosine squared of theta, can we like factor it out or do something?
What do you mean by factor it out? You can't factor it out. But you can do something with it.
What you did here, because
Yes, I think I still have it written up over here. Is that what you're referring to? Yes, let's make that substitution. Don't have to, there's other ways to do it, but let's make that substitution. So we're gonna make identity, so cosine is gonna be 1 minus sine squared of theta over 1 plus sine of theta equals. Okay, that's a good substitution, I like that. Okay, now I'm kind of tossed on this one. Should I give you the next answer, or should I see if you can figure it out? The next one's gonna be kind of tough to see, at least in my process. So, do you see anything we could do? Can't cancel anything, right? Because there's a minus and a plus, so we can't cancel it. Any ideas?
Now can you factor?
I'm sorry?
Now can you factor?
You can factor. Factor the top because it has the sine squared, so you can absolutely factor the top. How would you factor it?
Oh, take the sign out?
Can't take the sign because there's no sign here. There's no common factor between 1 and sine squared. A little bit of a hint. Okay. Do you guys remember back in Algebra 1 when you did the difference of two squares? We had x squared minus 4. And we factored it to what? X plus 2 and x minus 2, right? That's what we have right here. 1's a perfect square, sine squared is a perfect square, and it's the difference. So, whoever said factor was correct. We're going to go ahead and factor that top, and it's going to be 1 minus sine of theta times 1 plus sine of theta, all over 1 plus sine of theta. And you have the difference of two squares factoring.
Oh, can you cancel out?
Oh, then you can what?
Cancel it out.
What can we cancel?
1 plus sine of theta, 1 plus sine.
Why can we cancel them?
Because you're the same?
Because we're multiplying and they're the same. So they cancel out. And you're left with 1 minus sine of theta, which is what we're looking for,
Plus?
and we're done. I do believe we were looking for 1 minus sine of theta. There you go. This factoring is one I was kind of worried we wouldn't be able to see. So great job on saying factoring. Difference of two squares.
Wait, so we can use like any math, like even like the most basic of math for this?
You can do what?
Using like some of the even more like basic pieces of math for this?
The only thing you can't do is you can't add something to this expression. Because you can't add something because you make it bigger. So, and you can't add to both sides. You can't subtract anything. But if I'm going to multiply, I can multiply numerator and denominator by the same value. I can do that. But yeah. Adding and subtracting is the one that kind of has problems with that. Okay. Questions? You good with that one? Let's try one that's a little more challenging. I haven't practiced this one. See if I can remember how to do it. Okay. Here's another one. You just said basic. It's going to require, do you guys remember talking about the conjugate? Okay. So this is going to use the conjugate. Another tool you have in your toolbox that you may not remember. Okay. So if I have the sine of x,
Mr. Phillips,
or sine of theta, yes.
was the conjugate when we like flipped it or something like that?
Yes, so I can't remember, like if we had 4 over 2 plus 3i,
Oh, and then it was.
2
Yeah, okay.
minus 3i,
Yeah, I remember that.
and it's 2 minus 3i. So we can use that tool on this particular problem. Now, we don't have to, I'm gonna give you a chance to try it a different way, but the way I did it was this way. Sine of theta over 1 plus cosine theta equals 1 minus cosine theta over sine of theta.
That was my jam.
So what?
I don't know if I got it right on the test.
Maybe. Yes, I do. And they're fairly new ones too, I think. Okay. So if sine of theta over 1 plus cosine equals 1 minus cosine over sine, which one's more complicated? Which one's going to start off?
They're the same,
They're the same?
except one is negative. So you
Yeah.
can start on whatever side.
Yeah, you can start either side, I don't care. I'm going to use the left side, if that's okay with you. They're equally complicated. Okay, so let's use the conjugate in this case. Now, helpful hint. Amaya, you mentioned, well, these are the same, it's just they're different signs. Conjugate. Okay, these two are actually conjugates of each other. So let's use that. Okay, let's go ahead and multiply by 1 minus the cosine of theta on top and bottom. Now, I'm not going to multiply out the top just yet. I'm going to leave the top one factored out, okay? So I'm going to go sine of theta. And understand there may be times where you multiply it out, and then you're like 3 steps down the line, you're like, oh crap, I got to factor it back out. That's fine, that's part of learning, okay? It's okay. I'm just going to tell you we're going to leave it factored out. Now the bottom one though, I am going to go ahead and multiply. Okay? So, let's go, first of all, let's do parentheses, and then let's do this in green. Okay? What would be 1 times 1? 1 times a negative cosine theta? Negative cosine theta. Cosine of theta times 1? Plus cosine of theta. And cosine times a negative cosine.
Negative cosine squared.
Negative cosine squared of theta. Now, the reason we use conjugates is because these two middle terms always do what? Say it again? They always cancel. That's the reason why we use conjugates, okay? So let's go back to blue. These will cancel, and I'm going to be left with the sine of theta times 1 minus cosine of theta all over 1 1 minus cosine squared theta. All right? Now what?
1 minus cosine squared of theta, they both cancel out at the top.
No,
No?
because
The
this is
square.
just the cosine squared.
guys, sorry.
Those are two different.
Accurate.
If, hypothetically, instead of having this, we have 1 minus cosine of theta squared, okay, then you could cancel one of them out. It's not what it is though. Okay, what's that?
Factor out at the bottom, so that can cancel on top.
What do you mean by factor?
It's gonna be
Difference of
sine.
square. Are we
It's
gonna
gonna turn into one sine, one minus sine squared of theta, right?
Hang on to that thought. What did you say?
Are we gonna do the difference of squares?
So, if I do the difference of squares, this is just, I'm going right back where I started. And you will find yourself going, oh, yeah, the difference of two squares. I can do that. The sine of theta, 1 minus cosine of theta. The difference of two squares is going to be 1 minus cosine of theta, 1 plus, because I just learned that skill. They cancel, and I have sine over, which is where I started. Okay, so that will happen on your own, and that's fine. Just realize, well, that's not the direction I want to go. Now, you were very close on what you said. What did you say to do?
I thought that it would change into sine, but it's a negative, so it doesn't make sense.
1 minus cosine squared of theta
Oh.
equals,
Sine
Sine
squared of
squared
theta.
of
so on the bottom, ugh, how many times a day am I going to do that? What happened? So the top stays the same, sine of theta, 1 minus cosine of theta equals, and we said, let's change this to sine.
But it's, we still have our, we still can't cancel it because it has the squared,
What can we not cancel?
the signs,
Why can we not cancel the sine?
because one is squared and one isn't.
Okay, so a different way of writing sine squared is simply sine of theta times the sine of theta.
So all, they cancel.
So now you can cancel with one of them.
So can't you do that with everything else? Can't you do that with
So
the
it's-
cosines?
I'm sorry?
Couldn't you do that with the cosine then?
Up here?
Oh,
No.
why?
You're talking about right here,
Yeah.
1 minus cosine and 1 minus cosine? Okay, we explained that this here is not, I really hate this word. I used to like it, now I'm not so sure. 1 minus cosine of theta squared. If it was like that, the whole thing being squared, then I could cancel. But this is 1 minus cosine squared, so that, what that means is 1 minus cosine of theta times cosine of theta. Those aren't the same thing. And no, you can't cancel that, because 1 minus, it'd have to be the whole thing. Those are two different expressions. Okay, so then I'm left with one, oh wait a minute, that's where I was heading, right? 1 minus cosine of theta.
No. Wait. Oh,
Yeah.
yeah.
Over sine of theta. And we're done. And we can see that is exactly where I was heading.
Oh, boy.
You get this? Yeah. Maybe you get a 3? Oh, okay. So you're ready for the test?
No, a quiz.
Ready for a quiz?
Yeah.
I've got one. Here we go. Stephanie, here you go.
I'll take it back. No,
Why
no,
you
no.
Sorry.
saying
It's
that's
everybody.
It's
No,
the-
no, okay, not for everybody, but I'll take it.
It's the handout.
Way to ruin my fun, thank you.
How about so loud for no reason?
Okay, so my question is, how confident do you feel in trying these 4 on your own?
I feel like
All of them are like 2, maybe 3 steps, except for number 3. I think number 3 is probably the most difficult one on there. Would you like to try each of them on your own?
Yes.
All right, give them a try. I'll give you, let's say, what if I give you 15 minutes to try those 4 problems? I would suggest save number 3 for last. Okay, try 1, 2, and 4, and then come back to number 3. Nope.
Wait, when you say show your work and reason,
You don't have to give me your reasons. And showing your work is what we've been doing the whole time, so.
So like, Mr. Phillips, when you was in high school, and you did this, you was just walking on.
Did you, like, how fast did you?
How fast did you get on this, like in your high school days?
you can make it to regular.
Like in your day?
Okay. That's not what fair,
How is it not fair?
because math will just always come easy. It just has always made sense. I've always been able to figure out the big picture
So you kind of
So you just,
very fast.
you was just walking.
But that's not fair. It's like me, asking, ask me in English, how long did it take me to get a I still can't write a 5-paragraph essay with any sort of skill whatsoever. I mean, we had to do all these papers in college, I struggled through it. But you give me 50 calculus problems, I mean, those are good. But, so that's really, you kind of asked me about my strength.
I don't know what we expected to get to.
Yeah, it is, you draw literally the knife.
A lot of these here, I haven't seen.
wait,
I just look at
on
them,
the
like,
first one,
yeah, I can kind of see them. So,
I don't get it, on the
Not
first
always,
one,
but
there's
sometimes.
like, it says cotangent squared.
I don't really do well with
cosecant squared
computation, but
theta,
these type of things I just sort
but
of.
there's nothing
My
in
dad has
between
like a
that.
calculator in his head, and he was like, oh, they just got it, you have big numbers.
Oh, yeah,
and he like,
Mr. Jenner.
Mr. Phillips?
Like, all you have to do is break it down and throw it together.
Yeah.
I think,
Like, when it comes
There's
down to
tricks you
like,
can learn, but
when it comes down to like, let's say like, when you come up to the hardest stuff, I can't like figure out stuff. It comes to like, like geometry, I'd say, like, it was just like literally while I was a CPD class, every day, but like, it's just like, this is different, this is.
yeah, this is, I like this, I think it's more of a puzzle, and I like those challenges. Yes, ma'am. Amaya?
I mean,
What you got?
on these, it says cotangent squared theta. What is this one?
So there's nothing between these
So
times.
we all had the same like.
It's like you're multiplying.
So like, this is tangent theta times cosecant.
Correct.
They subtract, right?
It's just like a variable and a number.
they can't, cotangent and cosecant are multiplied together. Like if you want,
So if this was multiplication,
Why does every school do an estimate?
why you bring this for chicken wings? Wait. What is this in your hand? This and this. Or you gotta do multiplication first. Wait. What you gonna do? Oh, yeah, they do. Look at that. 45 piece.
Yeah, sit tomorrow during 8th hour?
Yeah.
Yeah, that's fine.
You're delusional. Evan, Dennis says that. Look, you look at the top of the functions people. What do you feel like? Sit up. Take a nice big seat. Africans will be coded. You know my birthday? All the Africans, like, all the Africans, like, I fucking wake up every day,
Right.
all day. I wish that girl, I wish she spoke English. I feel so, you haven't even said hi to her, I know you haven't. No, you haven't.
I have when I see her, I don't see her.
Honestly, she always spots wherever I'm at. I'm never lying. I see her a lot, actually. Yeah. So nice, so sweet. Probably is here one of these days. Who knows? Because, bro, sister
Okay,
kids,
well,
really,
I'm just gonna
everyone's supposed to be there, I promise you. Africans like to brag. Why are you working on the floor? Because, I don't know, that's the simplest. I feel like I'm being bullied. How did he even get?
Okay, somewhere in your notes, we actually did all of these before, so don't forget about these Pythagorean identities. The ones you have on your paper, we just rearranged a couple of them.
Really? Look. It's for number 3, right? If you substitute secant and then on the whole side, it's all the same. So can we just like forget about the whole problem? Are we even done a minus problem yet? Subtraction, minus, same difference. But you can only call it transfer when it's multiplication. So I don't know. Here, he said we should always get one. Wait, I don't know. I'm gonna make the memories the same. Which means I have to combine. Then we do sine times cosine.
theta and cosecant squared together, or just supposed to be a plus?
You probably want number one,
Yeah.
they're being multiplied with cotangent squared times cosecant squared.
Okay. And then we can reorder this, right?
To a degree, yeah. I mean, as long as the negative stays in front of the cotangent squared.
No, because I just multiplied all these together, so really everything's not gonna make sense. I don't know how you get to.
Figure out what.
Mr. Phillips, for number 3, is the first step substituting the top?
Number 3, what'd you do?
Is the first step substituting secant for 1 over cosine?
That's a possibility, yeah. It's not the way I did it, but that's a possibility. Now, here's something interesting. Not that you care here, but if I have the secant of theta over the sine, which is what I have there, right? So you said change secant to 1 over cosine, right? Over sine of theta? Well, if you keep, whoops, change and flip, because it's like sine over 1, then you would get 1 over cosine of theta sine of theta. Once again, just take the cosine and move to the left. So you could change this first expression into this. That's actually a trig I did in there too.
So I'm gonna erase all this.
That does actually help you.
I didn't do it like that at all. I substituted it, but then I try to make the denominators the same.
Okay.
So I multiplied from the top and the bottom to, I line it all out. But I don't see how it gets to cotangent if I do it like that.
So what did you get for the first one? You put in this and then you. Let me see what you got.
I already erased it.
Oh, well, can't help you if you erase it. Because I can see where that would get to the answer.
Is this?
All that work, I can see how you can get there. So, yes.
Oh, no.
So what?
Okay, for number 1.
So then my question is, what are you gonna do next?
I don't know. Because when I factored it, it didn't make sense.
Try factoring.
It just did, and it didn't make any sense.
Try factoring it, and then you may have something here to help you. Yes.
What's the opposite of cosecant?
The reciprocal of cosecant?
Yeah.
No, cosecant, sine.
Or another side, it's just sine.
One more side.
I don't know.
So what?
Can't figure out how to start on
So, kind of gave you a hint way back here. Let's go back and look at this one. Okay, right here. I said whenever there's something in common between them, that might be a good idea to factor that out and see what happens. So when you look at number 1, what do they both have in common?
If you combine the
No, they're just doing that with
cotangent,
one.
it's the same. They both be like, if you combine cotangent squared and cotangent squared, it would be
So they both have a cotangent squared, right?
change it back.
So factor that out.
do I change it?
Yeah,
Do I
I'm
change it
gas
to,
today, bro.
uh,
Dang.
do I need to change it when I do that?
You have to change it in, just factor it out, just like we did here with the 2. Factor out here with the 2, you bring the 2 out front, and then whatever's left. So bring the cotangent squared out front and write over whatever's left.
Go back to that page.
All that terrible factoring people hate. Yes.
Can we go back to that page that you were just showing?
This one?
Yes, but smaller, yeah.
My timer?
It's,
Oh, 3.
let's just end the time.
Yes.
I have a question, because I feel like where I am, he is my answer. What if it is cosecant? Would find that out?
That time is too.
I don't even know.
Let's see.
Erase it, you can't
So
help it.
back here you did tangent.
What's it?
You don't have much to erase.
Tangent times cosecant squared and then minus tangent, right?
That,
Minus.
yeah, I was just going to the
Erase it was so smooth, man.
Because
Wait.
I wanna go home this one,
Okay.
because in my mind, it really shades the same, but
It is.
of those scripts, I put up, so.
It is.
So I fixed it, and then I started to, I just follow the steps, and now I'm stuck.
So you took out the tangent, and you got, over here, you probably can't switch these 2. So you would have, if you took out the tangent, you'd have cosecant squared minus 1. So
Yeah,
my
so
question,
anyway,
why you switch
The
places?
graduation's gonna be in 2 weeks, but she's focusing on graduating. She's for a
Squared.
collective 3 people.
Correct, because you got cosecant squared minus 1.
Okay.
And then that
But
is
they
what our
don't even
identities.
know the plan. How you gonna write something you don't even know what's happening?
Mr. Phillips?
Wait, okay, wait, so what?
I can't see. I have like a possibly, not, I have a little bit of an unrelated
You know what, I'm
question.
actually gonna go home and print
Can you
these out.
spell pomeranian?
Then in your book, I'll never forget when you said your best friend wasn't
I like
right.
looked at my paper, right, and none of this right now.
It
What about
works.
is,
Wait, I
you
can
can spell
swear.
pomeranian.
Yes.
Wow.
Why did my
I
parents
honestly do
fire?
not know.
Really not.
And no, I'm gonna be a little more bold here. I'm gonna say, I don't even care.
Unfortunately.
Sorry.
That was like.
All right, let's go ahead and look through these. Due to time, you guys are leaving in about 20 minutes. I would like to get to one of these other ones. So let's try these 4. How many of you got at least one of them you think completely right?
Can you have water bottle cap, please?
All right, which one do you think you got completely right?
Can you have water bottle cap?
Number 4?
The 2.
Number 2? Number 4? Okay. How many of you got to all 4 of them? You tried all 4. Okay, couple. All right. Number 1, who was I helping with this one? Okay, so they both have a cotangent squared in common, right? All right, so you factored that out? What did you get?
I didn't finish it.
Well, let's do it. Cotangent squared of theta. So if I take cotangent squared out of both of them, what do I have left? Cosecant squared theta here. Minus, I took the cotangent squared out. There's just a 1 there. Now, we do have an idea. Whenever you see the difference of 2 squares, one of them being a trig function, one of them being 1, you probably have an identity. What does cosecant squared theta minus 1 equal? Cosecant squared minus 1. Cotangent squared. So this is cotangent squared theta times cotangent squared theta. And what is cotangent squared times cotangent squared? Did I look at yours?
Yes.
You were close.
No, not to that.
Okay, so your first step, yeah, that's why I was like, does that help you, or where do you go next? Yeah, but you can still get there. First of all, that's, oh, I didn't see this next one, you factor the difference of squares.
You two need to factor.
Yeah, I probably wouldn't have done that. Okay, so right here, rather than factoring the difference of two squares, what is 1 minus sine squared equal? Cosine squared. Okay. What does 1 plus cotangent squared? Cosecant.
That's what I have it there. I have that there.
Well,
I
how
got
did you get
there.
there? Oh my goodness, you did get there. You definitely did get there. Okay. So then what is, how'd you get a minus here?
The minus cotangent squared, that's just from up there.
Oh, just right then. You just
Hey.
I what?
Sorry, oh, I'm sorry.
So what is cosecant squared? That's like 1 over the sine, right? Cosecant?
Cosecant squared or just cosecant?
Cosecant. Cosecant is 1 over,
The sine.
so you can make this one
Would it be four over the sine?
1 over sine squared. And then cosine over sine is cotangent. You can get there. You could absolutely get there.
When did Spark
So I just took.
Well,
long.
okay, so point for everyone. Point for everyone. Right here, when you see the difference of two squares, if one of them is a trig function, think of Pythagorean identity first, rather than factoring the difference, which is certainly something you might want to think about. But if you can change it to another trig function, that'd be better, quite quicker. Because that's, I think, where you went astray. I think if you changed those two, you would have got there. Okay. All right. You weren't totally off. You were just
This guy.
scenic tour.
Yeah.
You would have got there. But do you see now, if there's something in common, just factor that out. Because when we look at number 2,
So is that what we're gonna do for the next one?
yes,
Okay.
do it right now.
Yeah, okay.
Take a second and do it. What do they have in common? Factor it out, you would have got there. See if it works. Can't tell me this is kind of fun.
It's fun because like.
This feels like watching.
You can go break down middle part of that. Can we go back to the identity? Ooh, okay.
That's crazy.
Probably chopped in my hair. Cosecant of theta squared equals cotangent. Theta squared.
Does that help?
I got it step further.
You got a step further? That's a good thing.
So I, like,
Watch that.
Let me go back to the other page.
Maybe I should just make a sheet and put it up here.
Yeah. Well,
Oh,
no,
yes,
I don't
please.
got, well, make a sheet, but I'm not gonna be able
Well,
see it.
I completely forgot about the items to post thing. I should have been using that. Dang.
Maya's the only one I think that's used it all year.
I'm finna log in, don't worry.
That's
You
the
can see a
one.
couple things on that list.
Then what?
Just take this and
Guys,
staple it
guys,
Not gonna lie.
how do you get to the
Just
final
one to some of that.
cotangent? Mr. Phillips?
I did that
Okay.
for one thing.
What did you do to get there?
I took out the tan and
The
then
items to post.
it's cosecant squared.
Okay, hang on. Hang on, let's see. You took out the tangent, and then I heard you say it's cosecant squared. Keep going.
Of theta, and then minus one, and it goes with cotangent squared of theta.
Minus 1. So then tangent of theta, you said this becomes what? You said cosecant squared minus 1 becomes what?
Cotangent squared theta.
Cotangent squared theta. I gotta get the cotangent.
Yeah.
Okay. Any suggestions? I'm sorry? You change what to 1 over cotangent? Oh, well, if I change tangent to 1 over cotangent times cotangent squared of theta, what's gonna happen? One of the cotangents cancel out one of these cotangents. So then it becomes cotangent
Smart skill.
of theta equals cotangent of theta. And you get the bonus point for that. There you go. One way to do it. Are you the one who think you got number 4 correct? Okay, and you think you got number 4 correct? Okay, you guys could fight it out. Who wants to come do it?
I don't.
You don't? Okay, you're out.
I wrote the.
Number 4.
you go.
I gotta sit down because my foot's recently been stepped on.
Sorry.
I think I have to go back to a cave.
What do you wanna eat? I didn't, I stepped on your toe.
I know, it's all black and blue.
So you get to eat at the room, basically.
When this foot was right here, and I stretched my.
You're gonna feel sluggish.
Is this our first one? Did you work on the right-hand side? Yeah, this is the first one we've actually worked on the right-hand side. I did too. Did you work on the left-hand side?
I worked on it.
I burned.
I don't want, I just wanna eat it. I don't need it.
What do you always do to finish off? One step.
Oh, yeah.
Nice. One step. Change that tangent and you're done.
Slay queen. You ate that up.
But I thought you
I thought you said
said
steak.
that 4 was gonna be hard.
So 3 was probably the hardest one. Very good. Same way? You did the same way?
Well, just, it's cosine times is sine.
So you did the same thing, just make that substitution?
I guess so, yeah. I just know that cosine times tangent is sine, because sine divided by cosine is tangent. Math.
Okay.
Why do you listen?
All right. Did anybody look at number 3? You were looking at number 3.
Scholar?
Scholar.
Yeah, you said
You were looking at number 3.
Guide, he'll guide you.
Let's take a look at number 3. You wanna try this one?
Not really.
Okay, well, you tell me what, okay, so I know what you did first. Okay. The first thing she did was replace this with 1 over cosine, right? Okay. So we did, I'm gonna change this to, so we did one, oh my god. One over cosine over sine of theta minus sine of theta over cosine of theta. Okay, now what did you do?
I combined the denominator.
So you got a common denominator, right?
Yeah.
Okay, so our common denominator is going to be sine of theta, cosine of theta. So then here you have to multiply by cosine of theta over cosine of theta. Over here you have to multiply by sine of theta over sine of theta. So what you did?
Yeah.
So here, what happens? You're just left with 1 minus, what's sine times sine?
Sine squared.
Okay? What next?
I don't know.
What do you think is?
I would say,
Fact.
What? Factor?
Wait.
What would you factor?
The 1
So I told you this earlier, when you see the difference of two squares, rather than factor, look for an identity. What does 1 minus sine squared equal?
oh, cosine squared theta.
Okay? It will work the way you're factoring it. You're just gonna go down a really long scenic road. Okay, this is just gonna be a little bit faster. I'm just trying to save you some time. Cosine squared theta over sine of theta, cosine of theta. Now what?
Do one of those cosines cancel out?
Yes, because they're being multiplied. This is like saying, just over here to the side, a little scrap work over here. This is like saying cosine of theta times cosine of theta over sine times cosine. So yes, they're being multiplied, they cancel. Cosine of theta over sine theta. And what does cosine over sine equal? Cotangent theta. Which I do believe
Yes. Phenomenal.
was where we were headed.
You say that's phenomenal. Why are you using such big words?
Which is where we were headed.
I really just needed a little bit of
So when you
guidance.
say
Can you scroll back up, please? Thank you.
Okay. So, question? Someone had a question? Someone said something?
I should have just kept going.
I remember.
You were gonna get it?
I feel like I was. I think I just need to take the self-doubt.
Are we keeping this or are you taking this?
No, keep that. That's part of your notes, examples. I have some more for us to look at tomorrow.
So when you say multiply, you mean like if the equations are multiplied?
Not equations, say expressions. If the expressions are being multiplied, you can cancel. Yes. Good question. Else? Others? Anything?
Will it get harder than this?
Oh, yeah.
Oh.
Oh, well, like,
Will it always be like theta or numbers?
We're not gonna use numbers. There'll always be some sort of letter. Sometimes it'll be A, sometimes it'll be, sometimes it'll be X.
So the problems get.
I just use theta because it's easier to write.
But the problems get like longer.
Will the problem get longer?
Grandma's playing.
It was. I typed in other people's messages.
Let's